Hello. Today your attention is invited to the third lesson on the subject of chemistry. The theme of today's lesson, physical and chemical changes. Also we will talk about physical and chemical properties of matter. Let's start our lesson. To start, we briefly repeat the material of the previous lessons. We are all surrounded by various objects on a daily basis. Anything that we can use, touch, eat, etc., is an example of object. Let's remember the definition of the term object. Object: this is a material thing that can be seen and touched, and it occupies a certain place and volume. It is absolutely obvious that different things have different properties. Take for example two different objects, a metal bolt and a rubber ball. It is not possible to squeeze the metal bolt, while the rubber ball can be easily squeezed. As we have been already known, the difference in the properties of different objects is due to the fact that they consist of different substances and matter. This is anything that has mass and takes up some space. Both the metal bolt and the rubber ball are objects, because both of them are an identifiable collection of matter, which may be constrained by an identifiable boundary, and may move as a unit by translation or rotation, in three-dimensional space. Objects consisting of the same substance have the same physical and chemical properties. Look at the picture below. The objects depicted in the picture have different shapes. However, both the iron bolt and the piece of iron consist of the same substance, namely the chemical element of iron. Let's remember the definition of the notion of element. The substance composed of one type of atoms is called element. From what has been said above, we can draw the following conclusions. Objects that composed of same matter display same properties, and objects that composed of different matter display different properties. Let's define the notion of a property. Property: this is a quality in a substance or material, especially one that means that it can be used in a particular way. For example, good conductivity, malleability, and inherent shine are those properties that the element of iron possesses. The same properties will have objects that are made of iron. There are physical and chemical properties of substances, and objects consisting of these substances will also possess same properties. Physical property: this is a characteristic of matter that can be observed with senses or can be measured. Physical properties are used to observe and describe matter, and they can be observed or measured without changing the composition of matter. Physical properties are divided into intensive and extensive. The intensive physical property: this is a property that will be the same regardless of the amount of matter. The intensive physical properties include: first property, color. The quality of a specific object or a substance with respect to its ability to reflect or emit light of the specific wavelength. What is visually determined by human light: definite color, for example red, blue or green, etc. Second property, concentration. The relative amount of a particular substance contained within a solution or mixture or in a particular volume of space. The third property, density. The degree of compactness of a substance, in other words, the number of structural units of a substance, such as atoms or molecules, in a given space or volume. The fourth property, melting point. The temperature at which a given solid will melt. The fifth property, boiling point. The temperature at which a given liquid boils and turns to vapor. The sixth property, pressure. The continuous physical force exerted on or against an object by something in contact with it. In fact, the list of intensive physical properties is somewhat larger. Sure enough, we will focus on all of them, however not on this lesson but on later lessons. Extensive physical property: this is a property that will change if the amount of matter changes. Extensive physical properties include such property like length, the extent of something from end to end. The second property, mass, the amount of inertia, the mass equals to the weight. The third property, volume, the amount of space that a substance or an object occupies. Again, there are more extensive physical properties than it was mentioned above. We will talk about them on other lessons. But now, to better understand the difference between intensive and extensive physical properties, let's consider the next example. Imagine we took a piece of iron of mass of 1 kilogram. This piece of iron occupied some space. We tried to squeeze it, but we did not manage to do so, because iron possesses a high hardness. Then we bisected that piece of iron into equal halves. After that we chose and left only one piece of iron. The piece of iron that was chosen by us weighed only a half of the mass of the initial piece of iron. Its mass was only half of the kilogram, and that time it occupied much less space. And again we tried to squeeze piece of iron. We did not manage to do that again. Even much smaller quantity of iron still had the same high hardness. So, hardness is intensive, but mass and volume are extensive physical properties of matter. Chemical properties are any of the properties of matter that may only be observed and measured by performing changes to internal structure of matter. Simply speaking, chemical properties cannot be determined by physical methods of substance research, such as instrumental measuring and testing, or as well as by simple measuring the linear dimensions, weighing, touching, and observing for objects. As example of the chemical properties of the specific substance, we may cite on the property called the reactivity. This property of substance is its ability to react to the presence of other substances. For example, all of us are very well known about corrosion of iron. It corrodes through the reason of good reactivity to the oxygen, which molecules are present in the atmosphere of the Earth. In the process of corrosion, iron atoms create the bonds with oxygen atoms, as shown below. During later lessons, we will talk a lot about chemical properties, but to this moment, all you need to realize is that main indicator that will help you differing between physical and chemical properties is the answer to the question, are these properties determined without changing the identity of the substance, or not? If properties of matter determined without changing its internal structure, then they are physical properties of matter. Otherwise they are chemical properties of matter. Now, let's define the notion of a physical change. Physical change: this is change in which the matter's physical appearance is altered, but its internal structure remains unchanged. Perhaps it will be difficult to find a candidate better than the water as an example to explain what just was said above. Let's get acquainted with the building block from which the substance of water consists of. So, the structural element of water is a water molecule that is composed of one oxygen atom, chemically bonded to two hydrogen atoms. Below is a ball model of the water molecule. In this model, the red ball represents an oxygen atom, and the white balls represent hydrogen atoms. As we all note, water at a temperature of about 0 degrees Celsius and below freezes and turns into ice. Ice is a solid state of water, and you have probably already heard that the particles that make up solid bodies are packed enough close to each other to cause the forces of intermolecular interaction between them. Let's see how the molecules of water in the ice are arranged, and what structure they form in this case. As it can be seen from the figure, in the ice the water molecules form a multidimensional honeycomb structure. The next picture shows to us how the molecules of water are arranged in the liquid. In a liquid, water molecules are still close together, but they aren't anymore in a fixed arrangement like it was in case with ice. The intermolecular bonds constantly break and reform. But the most important for us is that both ice and water are composed of same building blocks. Ice and water are composed of water molecules. Let's see how the molecules of water are arranged in a steam. As known, to get a steam it is simply necessary to heat water up to 100 degrees Celsius. Steam, also like ice and water, is composed of water molecules, but this time between water molecules exist little to no forces of intermolecular interaction. In ice, the water, the steam possess different physical properties. Ice is a solid body, when water is a liquid, but steam is a gaseous substance. But all three substances are composed of same building blocks. All three, the ice, The water and the steam are composed of water molecules. What happening with water when it freezes or when it evaporates is called the physical change of substance. Physical change means that we can observe only change of physical properties or physical appearance of objects, like in case with water. When the same substance at different temperature can be solid, liquid or gas, but composition of particles of the matter of those objects remains unchanged. As another example of physical changes, we will give an example of dissolving sugar pieces in water. Before dissolving in water, sugar pieces are objects with inherent properties of solids, the main ones of which are permanent shape and volume. However, after dissolving sugar in water, we will no longer be able to distinguish its molecules in solution. Nevertheless, after evaporation of water we will again be able to observe solid crystals of sugar. In the above example, the substance has fundamentally changed its appearance. And despite this, we can definitely state that only physical changes occurred with sugar, since we were able to restore it from an aqueous solution, using only a physical method called evaporation. Now, let's define the notion of chemical change. Chemical change: this is the conversion of the initial substance into another substance. The newly formed substance will differ from the original substance by its internal composition and will possess unique physical and chemical properties. Chemical changes in the vast majority of cases occur due to chemical reactions. In addition, chemical changes are direct evidences that the chemical reaction is taking place. Chemical reaction: this is interaction between two or more substances called reactants. The result of such interaction is formation of one or more substances of entirely different composition from the original substances. These substances are called reaction products. The examples of chemical changes are the corrosion of iron, burning rubber with the formation of soot, and carbon dioxide. Let us consider an example of combustion of methane. The combustion of methane is the interaction of methane with oxygen. In the course of the reaction, one molecule of methane is interacting with two oxygen molecules. In this reaction, oxygen and methane are the initial materials. The initial materials of the reaction are usually called reagents. As a result of the reaction, one molecule of carbon dioxide and two molecules of water are formed. Carbon dioxide and water are the products of the reaction. During the reaction, a thermal energy is released. During the reaction of methane combustion, recombination of the atoms that entering into the composition of the reagents takes place. Two hydrogen atoms from a methane molecule combine with one oxygen atom and form a water molecule. The other two hydrogen atoms also combine with one oxygen atom and form a second water molecule. The remaining oxygen molecule and the carbon atom interact with each other. The result of this interaction is a disintegration of the bonds between atoms of the oxygen molecule, and creation of new bonds between the oxygen atoms and the carbon atom. That atom's recombination results in the formation of a carbon dioxide molecule. And now let's briefly repeat the material of this lesson. What is the meaning of the term property? Property: this is a quality in a substance or material, especially one that means that it can be used in a particular way. What is the meaning of the term physical property? Physical property: this is a characteristic of matter that can be observed with senses or can be measured. What is the meaning of the term intensive physical property? Intensive physical property: this is a physical property that will be the same regardless of the amount of matter. What is the meaning of the term extensive physical property? Extensive property: this is a physical property that will change if the amount of matter changes. What is the meaning of the term chemical properties? Chemical properties are any of the properties of matter that may only be observed and measured by performing changes to internal structure of matter. What is the meaning of the term physical change? Physical change: this is change in which the matter's physical appearance is altered, but its internal structure remains unchanged. What is the meaning of the term chemical change? Chemical change: this is change in which the internal composition of the original matter is altered. Good job. Thank you very much for watching this lesson.